Welcome to the PELS webinar series. Thank you for joining. This webinar is presented by TC12 Energy Access and Off-Grid Systems. Today we bring you a PELS webinar entitled Energy Access Solutions and the Role of IEEE Global Initiative Empower a Billion Lives. First, we have some housekeeping announcements. Today's webinar will be placed on the PELS Resource Center within the next week. We invite you to use the questions function on your panel to ask any questions you may have regarding the content or the broadcast related issues. Questions regarding content will be answered verbally at the end of the webinar. Information on how to request a PDH certificate has been sent to you via the chat function and will also be included in the follow-up email you will receive within 1 hour of completion of the webinar. I now welcome Isa Battersett to begin the presentation, and we hope that you enjoy the webinar.
I'm so sorry, I lost your voice. Can you hear me?
Yes, we can hear you.
Yes, sir.
Can you hear me?
Yes.
Oh, hello, everyone. Welcome to the IEEE webinar series organized by PELS Technical Committee. My name is Isa Battersett. I'm from the University of Florida, and presently I am the chair of the Technical Committee on Decentralized Systems. Let me turn off the camera. Decentralized Systems for Energy Access Solutions. Today's webinar is sponsored by TC12 itself, and we're really excited to have our inaugural webinar be presented by two great speakers, world-renowned in energy access, Professor Elena Popovic from University of Twente from the Netherlands, and Professor Deepak Divan from Georgia Tech. The title of their talk will be Energy Access Solutions and the Role of IEEE Global Initiative Empower a Billion Lives.
Presentation for us.
Thank you, Haibing. So I'm just going to get started with the presentation, and I hope you can see the right mode now. If somebody could just
that's good.
Give me a sign if that's good. Thanks. Welcome, everyone. Haibing, thanks so much for the introduction and for already sketching part of what we're doing within PELS and within TC12 to address this enormous societal challenge of energy access, but also to engage with this incredible opportunity for us as a society, as PELS, as researchers, innovators. And we hope to sketch today to you what this challenge is about. How does it link to the bigger picture of energy transition and what the opportunities there are, and an invitation to engage. And more specifically, to tell you about the initiative that IEEE PELS has been running for a while, for a number of years, and this is its third round, which is a global challenge that Haibing already introduced, Empower a Billion Lives. So Haibing has introduced me, so I'm not going to go into details. What I do want to share is that hopefully I can bring the perspective of both academia and innovation, but also of the broader sector through my involvement with the Netherlands Enterprise Agency. So it's basically more on really what is happening in the sector, what are partnerships that are active, and what does that market development look like. So I hope to bring a holistic perspective to this challenge. So let's start with where this challenge really fits in a big scheme of things. And we all know that one of the biggest challenges of our time is changing climate. And we know that addressing climate change is largely an energy issue. 75% of the emissions come from energy. And this is why one of the major global goals that we globally have agreed to, Paris Agreement, has committed to reduce emissions by 45% by 2030 and reach net zero by 2050. So under this big global goal, we also have a kind of a blueprint for sustainable development, for global sustainable development, expressed in 17 sustainable development goals, of which one is access to affordable and clean energy. And this is obviously closely linked to Paris Agreement and to the climate goals, but it's kind of split into three parts, into three targets. And one is ensuring universal access to affordable, reliable, and modern energy services. And this is both on electrification and clean cooking. The second target is increasing the share of renewable energy in the global energy mix. And the third one is doubling the global rate of improvement in energy efficiency. And while the second two targets, so increasing the share of renewable energy in the global mix and improving energy efficiency, are really showing great progress. And this is largely through well, increasing share of renewables in electricity generation, and actually electricity being a larger part of energy mix as we go along, and also increasing energy efficiency. We see that on the side of the first target, achieving universal energy access, we're really not making a fast enough progress. If you see on the right-hand side, there are results, or actually numbers from the tracking report that a number of global agencies are doing. And we can see that at the moment, almost 700 million people still have no access to electricity, and 2.1 billion people have no access to clean cooking. What is remarkable is that if we continue with business as usual, in 2030, we will still have 660 million people without access to electricity, and 1.8 billion people who are still cooking on traditional biomass fuels. And on top of this, there is also about 2 billion people who do have access to electricity, but this access is unreliable. I will tell a bit more about this later. So the progress is slow, and the way that we've been going about it has really not delivered the right, perhaps the right type of solutions, and certainly not the right social impact that we would like to see. So if we think about why this is problematic, what is actually the societal cost of the lack of energy access? First and foremost, it's a health issue. By cooking on traditional polluting biomass fuels, about 3 million people die each year due to particulate matters that are ingested and that cause all kinds of respiratory and cardiac problems. And just for the order of magnitude, this is more than what AIDS, malaria, and tuberculosis kill in a year. So it's a massive health issue, human cost. It is also really expensive to be energy poor. If you make a quick calculation, how much do you pay per year to charge your cell phone? Yeah, it's really peanuts. But if you live in rural Kenya, you likely have to walk quite some kilometers to such a kiosk where you can charge your phone, and you pay 25 times more than what you would pay, say, in the US or in Europe, while actually having much less disposable income. So it affects all aspects of human life, inclusion in modern society, and access to education, access to financial inclusion. So it's really a multifaceted problem. And on the right-hand side, you can see what it looks like on a country level. This is a picture that's probably driven most public investments into energy access, where you can see a correlation between electricity consumption in a country and well-being of its citizens. Disclaimer, this is a correlation, so it does not mean that providing energy will solve all the problems, but you can see very clearly how they are related. And you can see that especially in this first part of the curve, so until about 1,000 kilowatt hours per capita, this is where real progress is made by increasing electricity consumption and the well-being of the citizens of that country. So this is really where a lot of progress can be made. And I already mentioned that UN has created this global call for 17 Sustainable Development Goals. But if we really look into it, energy or Sustainable Development Goal 7, access to energy, is at the heart of it. It enables, and here I've just shown a few snippets from different impact studies on access to electricity in this case, and what it does to increasing income, for example, for rural farmers who now with accessing solar irrigation can sometimes triple or even quadruple their yield, to increasing number of hours in the evening that children can study, to improving safety and economic opportunities of women, to creating jobs, to reducing health issues, as I already mentioned, by not using, for example, kerosene lights, to reducing malaria cases because there is lights when you go to fetch water. So it is really at the core of all development, and this is why it is an issue that's really been receiving a lot of global attention, and while the progress is still not sufficient, as we already mentioned. So I will zoom into electricity access. We will talk a bit about clean cooking later in the context of Empower Billion Lives, but now let's just focus on electricity access, also given our community. Acknowledging that this is an issue where a number of solutions, and we will talk about them in a bit, are popping up. It is not a question of having access or not necessarily, or not only. There is a range of electricity access that a household or a community can have. And this is what has been mapped as tiers of electricity access in so-called multi-tier framework of the ESMEC program of the World Bank. And what it's basically meant to do is to indicate what is the level of quality of access of electricity. So, and that is mapped on a number of attributes. So not only power capacity or daily energy that a household can have, but also how affordable, how reliable, what's the power quality of this supply, down to its health and safety attributes. So if we look at the first two attributes, capacity and availability, we can see that we start from basically no access, or perhaps only a small solar light. Then we move on to tier 1, which still is largely lighting only, and perhaps a few lights. Tier 2 that has some basic appliances such as fan, maybe a television, charging cell phone. And then we go up having more power consuming appliances. So it is also meant to track progress in the sector, and we will reflect on that in a minute. So if we look at the solutions that are out there to achieve electricity access, the solution that has been receiving most of the finance, both public and private, is really extending centralized grid. And the decentralized grid is, this approach is basically on the assumption that if the supply side is there, if the grid is built, that the consumers or the demand will come. And this has largely not panned out. If we look at the state of electric utilities in sub-Saharan Africa, we see that basically 95% of them are not covering their operational and capital costs. And it's a complex issue and has to do with many different aspects, but one of the core parts of it is low electricity demand. If you look at what a utility would have to cover its cost, which in many cases it's 100 kilowatt hour a month up, and if we compare it to average consumption of a household in say even Eastern Africa, which is more developed generally compared to say West Africa, this is really almost an order of magnitude less. Another problem is that even if the grid is there, they are in many contexts largely unreliable. And I think the most prominent example is Nigeria, where 80% of households connected to the grid have no electricity half of the time. So you can imagine what that does to functioning of a household. And this is, for those who can afford it, mitigated by having a diesel generator. of which there are 7 million deployed on the continent, with all the environmental and greenhouse gas pollution consequences that come with that. And we see this also happening in other countries, and even countries that had reliable access to electricity, like South Africa. We can see that with increasing demand, with struggling utilities, that this access to reliable electricity is really not a given anymore. And of course, it's also a political issue where utilities are, or where governments are trying to kind of deliver on this promise at the cost of profitability and basically making sure that that costs are covered. And even for context where there is a grid, there is an issue of being under a grid, as it is known, which affects more than 100 million Africans in urban areas who actually live close to the grid but have no access to it for a number of reasons, including but not only a high cost of connection. And I think if we sum that up, that is best illustrated in this picture that a student of ours made a few years back in North India, where a household lived next to the grid lines for 10 years without having access to electricity, and for which reason they used small solar home systems, a small panel and a small battery for their really basic, to power their basic appliances. And you can also see how they cook with dried cow dung, and then that gets, as I already mentioned, with all the consequences of indoor pollution that come with it. So this is really such an illustrative picture of the basically failing of a central electricity grid as a solution. So as a response to it, more decentralized solutions, and then specifically standalone household solutions like solar home systems and mini grids have emerged, largely private market driven, with a promise that the market will solve this electricity access problem. That if the solutions are tailored to what customers need, and if there are right delivery models, that this that the market will solve the energy access problem. And I mentioned there are generally two types of solutions. One is standalone, really for single household, and you can see it on top of the picture, which typically has a small panel, let's say up to 50 watts peak, a small battery, and delivers with it a number of appliances. And there is a community solution, which is a mini grid with obviously larger installation of solar panels, a battery bank, and then distribution lines to households and community institutions. And typically, if we look on a country level, they are mapped so that looking at the whole country, that the most optimal solution in areas that are very close to the central grid would still be the central grid. If, and this is what you can see on the left side of the picture, if we move more towards areas that are removed from the central grid, but say more than 20 kilometers, but still have kind of sufficient density of population and of economic activity, that's where mini grid would make the most sense. And then for really dispersed rural areas with low demand, solar home systems would be the most promising solution. But if we look at the progress that has been made, these solutions, and in particular solar home systems, have reached well, over 170 million people. But if we look what it really looks like, most of them have been reached with tier 1. And tier 1, as I already mentioned, this is basically a light, or at best a couple of lights. So only 5 million people have reached this tier 2, which enables you to have basic consumptive appliances, and in some cases even some basic productive energy use. So this is really problematic from a number of perspectives, both from affordability perspective, which is one of the reasons why progress is not going as fast as we'd like. In the case of solar home systems, it's also problematic that the number of loads you can power is limited, and especially that it does not power appliances that can generate income, which is referred to as productive energy use. So you're basically still stuck in the poverty cycle. And in the case of mini grids, what is really plaguing mini grids is getting the business model working, which again is back to the demand that in some cases is overestimated, which then makes it difficult to recuperate costs. And I will tell a bit about later that in the case of mini grids, specifically in certain types of operations, that sustainable operation is really a major issue. And then if we look at what solutions are out there, but what do people actually want? And this is an example of a field work of a PhD student in our group who was doing work on an island in Indonesia, in Southeast Sulawesi. And what she has come up is a number of through a specific method. What do actually people want from, specifically in this case, from a mini grid? I don't want to go through all the points, but you can see that on one side is what people really want, what they are aspiring to. On the other side is what they fear that this solution is going to bring to their households and communities. And if we kind of aggregate it, what it comes down to is that they want appliances that can power their livelihoods, including productive use of in the agriculture sector, so really being able to irrigate their crops, being able to process their food and make income with that, to power communication, to power mobility, and to increase quality of life. So access to water, access to health, access to education. So it is really not a question of access to electricity for its own sake, but it is what electricity does to the households. And what I also want is a sustainable operation. We see in some contexts that failing infrastructure is really damaging the reputation of solar technology, of mini grids, of even solar home systems. So this is really a top priority. It should be affordable, but surprisingly, this is not the first, or let's say the most important criteria that we always think about. So it's not only about affordability, but it's also about how much people are willing to pay for a service or for product. What is also interesting is that especially on the fear side, is what that access is going to do to the community dynamics. So it's really an issue that is not only technological, it is not only fuel issue or energy issue, it is really about what it does to social fabric of a community. And they are worried about what energy access, so not necessarily electricity, but what broader energy access is going to do to the environment. And in this case, they mentioned mining activities and then the energy that would power it, but also how paying for this service, for electricity service, is going to work, or how it works. Is it fair? Is it transparent? Is there corruption? So this is really broad expectations of societal aspects of access to energy. And then if we zoom into what this reality on the ground looks like of energy access, what we see is, if we look at technologies, we can see that, as I already mentioned, on one hand we have centralized, and the other hand we have decentralized solutions. We can see that these parts are developing almost independently, that there is very little alignment except for this very high level integrated energy planning on the country level, which maps which solution comes where, but there's really very little alignment also in terms of interoperability between different solutions, both centralized and decentralized. So what happens if there is a microgrid and then the central grid comes in? So this was also one of the fears in the case of Indonesia. So these solutions are really developing on their own islands, not only technologically, but also in terms of stakeholders. Utilities are not involved in the discussion on decentralized solutions and how they develop. And we see that friction really playing out in the field in many contexts. And also what we see is that the context where there is already existing solutions, so either the grid is weak or there is a grid, but people are not connected, these contexts are largely left behind. So this is a massive issue of what I mentioned earlier on, 2 billion people. As I mentioned, it is not only a question of technology pathways that are developing in isolation, but it's also how organizations work in their own silos, in their own networks. And of course, this has to do with different agendas of organizations, whether it's governments, whether it's multilateral development institutions, whether it's private sector. So everybody's working with own time horizons, with different targets. If we look at the public funding that is coming from the West, let's say from the global North, this is really largely driven by the by 2030 agenda. So connecting as many people as possible by 2030, while the quality of access is less pronounced in the targets. And also, this is of course coupled of what does this success look like if we are in 2030 and everybody has a solar light? Is this success? So there's really different visions, and by proxy, different pathways to addressing energy access, and this is really problematic. And of course, all of this also comes down to why is it difficult to scale energy access solutions? It comes down to affordability. It comes down to how viable the business models are. As we mentioned, the decentralized solutions are more private market driven, but it also has to do with how do we deliver to the customers that are not only that have limited income, but also are physically remote with poor infrastructure and less developed distribution channels. And I've already mentioned this, but one of the challenges is really how sustainable the operation of some of these systems are. This is really kind of multidimensional. It's not only technical operation sustainability, it is also, is there a capacity in that, is there human capacity in the context to actually service this microgrid when necessary, and what is the response to it? How can this be done differently? And also market sustainability. Once public funding, once donor funding runs out, does that market really continue working, or does it do the volumes decrease? And you can see some of these challenges in the pictures again from this from our project in Indonesia, where you can have on top right, you can see connections for a single household, both from the central grid and from a microgrid. You can see how difficult the contexts are. This is a floating village, so you can imagine that bringing infrastructure there is very different to bringing it to a context that is close to an urban center. And the bottom right, you can see what appliances you cannot power with your electricity supply. So it's really the capacity is limited, which means what you get out of that supply is quite limited. And maybe just to zoom into this sustainability issue, I think this is something that we as a technical community can kind of also get surprised or sometimes a little bit despondent. And this is specifically the case of sustainability of mini grids again in Indonesia. And we can see from different pieces of research what this actually looks like, that in many cases very shortly after deploying infrastructure, that the infrastructure, that mini grids are not working. So households that have enjoyed electricity access for a number of months all of a sudden don't have it. And it comes down to different different problems. Some of them are very technical, the wrong choice of components, batteries that are not cooled properly, that are not cooled according to specifications, but even high quality equipment that is simply not suitable for, or is not designed for example, for humidity or for temperatures. There are power quality issues, burning conductors, harmonics. There's also basic maintenance of what you can see in solar panels. So there's really a very complex issue of what goes wrong. If that is mapped onto the different causes, we can see some of them that I already mentioned. But what we can also see is that this agenda of trying to connect as many people as possible as the primary driver, also for private sector, because this is how they raise money, and this is how they get subsidies. That sustainability is kind of well, less prominent on the agenda. There's less incentive to invest in that. And by and large, in case of mini grids, these are customized solutions which actually require that if something goes wrong, that there is a typically very expensive expert that has to be flown in from Germany or the US or somewhere in an urban area. So this is really, in terms of sustainability and affordability, not ideal. So, and maybe this is, I hope this works. I just want to give you an kind of idea of what that looks like in a remote area. So what you can see is if we're going for remote, for perhaps island context, but even or mountainous dispersed, there's really a lot of issues that you have to keep in mind to ensure that this operation, once you deploy the infrastructure, it actually continues working. Because if it doesn't, then most of the time it just well, does not work anymore, and with all the costs to the community and to actually to the assets. So what needs to happen to address this? And I think it's again, there is no silver bullet. As a technical community, we're looking at how can we foster innovations, how can we foster solutions that address some of these issues that we talked about, that operate sustainably, that can grow as demand grows in a community, that are interoperable with each other, and that are actually coming from not from technology push, but they're coming as a response to the larger societal goals and impact that needs to be created. And with that in mind, we're also looking at how does this work as a kind of part of the larger energy transition challenge, but also opportunities, and how can we leverage the technology developments that are happening in the global north to address the energy transition for energy access context, so that they can leapfrog the solutions that we had in the 20th century and that are clearly not working in these contexts. And what you see on the bottom left is a quote from a consultancy report that really kind of plays in that or demonstrate this connection, where and specifically for power electronics companies and for power electronics industry, some of the most exciting applications are really in the energy access context, in off-grid context. So this connection between energy access and energy transition is really something that needs to be leveraged more, and I think Deepak will go more in that direction. Beyond technology, the solutions that we develop really need to be developed in ecosystems, and I will tell a little bit also how we go about that with Empower a Billion Lives. it's a solution to a societal challenge that is enabled by technology, but it still needs to work in a specific context, which means that a number of the different stakeholders need to be involved to get to that solution, to understand what is needed, and to actually be able to deploy the right type of solution. This also holds for academia. The way we work typically in our own kind of relatively small networks, and typically in the global north, that is not ideal in solving this issue. But also we need to engage with stakeholders that are outside of perhaps our traditional power electronics domain or power electronics networks, because if we don't do so, then the agendas for solving energy access will be shaped without input from the technology society that actually understands how these technologies can be leveraged to achieve what we just mentioned, to leapfrog the suboptimal solutions in solving energy access. And now I want to, now that we kind of showed a path what needs to happen, I want to reflect on what we are doing as a community to contribute, how we are implementing this. And one of the main pathways is the initiative Empower a Billion Lives, which is a global challenge to really foster this type of innovation that is calling for solutions that are scalable, that are regionally relevant, that are designed in an interdisciplinary way, and that leverage these technological developments that enable the leapfrogging that we're talking about. So we're looking at it as not only a technological issue, but we're looking at it as technological impact and business issues. So we're really looking at solutions that can address all three of these aspects of the pie. And the challenge has been running, this will be its third round. In the meantime, in the previous two rounds, we had almost 600 teams that registered, and in the two rounds from really all over the world. And the intention is also that this is a continuous process where we learn from the previous cycles, and we see also teams that are coming back and presenting new solutions that are more scalable, demonstrating impact, and it is really an exciting initiative that is happening. And again, this is all with the view of how can technology deliver on meeting the social impact, and how can this happen with business models that enable scale. This is a snapshot of the global finalists and winners from the previous round, from Empower a Billion Live 2023. And you can see that they come from different, they belong, or they won in different categories, addressing different type of solutions, but also different problems. You can see there are centralized solutions, more decentralized. There are solutions that are focused on enabling automated operation, so really to address this issue of sustainability, but also perhaps of optimal sizing of solutions. We also had a winner on end-use energy, so really productive use appliances and clean cooking, and the best solution for biggest societal impact. I will, and the grand prize winner. And I want to illustrate some of these, some of the contributions, and in particular from the technology perspective, so that you get an idea of what kind of solutions we're getting within the competition, but perhaps also where further improvement is needed, or a different take on a problem. And as I mentioned, it is all so that societal impact can be achieved. It is not only about building mini grids or solar home systems or whatnot. It really is about what is happening by doing so for communities that these solutions serve. This is a kind of a snapshot on what the winning teams of the previous two rounds of the Empower a Billion Live competition And what have they achieved? How many households they reached? How many individuals? How they addressed food insecurity by supporting smallholder farmers who can now irrigate their crops or process their food that they can sell. They can cool their produce, and by doing so, sell it at a higher price. To social institutions, to health institutions, but also the contribution to climate mitigation by reducing CO2 emissions, and some other impact dimensions. So it's really impressive to see what impact has been achieved by our teams. And now, as I mentioned, I'd like to just walk you through a number of solutions. These are winners from the previous round of Empower Billion Lives, and try to sketch how they managed to address some of these challenges that we talked about: affordability, sustainability, powering productive use, how they did that with their innovative solutions. And what you see here is the winner of the centralized category. And it's a company from South Africa and Zambia that is developing and deploying microgrids. And if you remember what I mentioned that microgrids typically struggle with, is making sure that the demand for electricity demand for microgrids that they develop is well matched to the supply, so that the operators or the deploying companies can recover their costs. And the way they addressed that here is by not selling electricity as kilowatt hours, but really selling it as what they call power time. So they sell a package to a household where they get certain type of appliances for a number of hours per day. So they have these packages that are very well thought through based on what their communities need, and this is how they operate their microgrids. It's really about addressing the customer demand, and they do so by also having they're called standard microgrids. So they really have these approaches of standardized solutions that they can deploy quickly, I think within a couple of weeks, and that they are modular, so they can grow from let's say, I think in the case of battery capacity, 30 kilowatt hours, and they can just kind of stack it as they go along, and they fit in shipping containers. So it's really also logistically optimized. And looking at their technology stack, what they call it, it's really a combination of smart metering, so being able to smart metering and load control, being able to actually implement this power time service that they have, so that if a household is using more power than they have subscribed for, that they paid for, then that those appliances can get cut off, but also that they can gather data from the usage, so they can optimize their operation of the microgrid, but also their business intelligence, so that they can tune their design, the services to the customer, and also the customer management, the communication. So how that enables more automated, less human intense type of operations, so that they can really streamline their operations. So the next example is a winner in the automation-centric category. And what they addressed is, again, this capacity problem of a microgrid installation that is actually typically oversized based on the demand. But actually, what happens is that appliances that, even when there is capacity, appliances that consume higher power or need more energy during time, that are not actually used in a microgrid. So this is what they're trying to address with load control. So basically enabling households that are connected to these microgrids to also connect some of these bigger bigger appliances, and this is in the context of Malaysia and the Philippines, where, for example, a rice cooker is really a desirable appliances. So what they do is they're communicating the capacity information on the generation side to the demand side, where then the appliances can be turned on and turned off either automatically, or the customer can have a control of it. So they have different implementations, and it's really about ensuring that the infrastructure is used at its highest capacity for the demand. So what they managed to do with that is to really enable use of higher power appliances such as rice cookers, such as refrigerators, and by doing so, really affect lives of the households in the communities, so that they can use, for example, power tools to run their workshops. For women, that they can use washing machines and reduce number of drudgery of doing household work, and of course creating economic opportunities in many different ways. So it's a very technology-driven solution or technology-enabled solution that has very tangible impact to the users of the microgrid. I also mentioned that we had a winner in the best or the highest impact category, and this is really a very perhaps the most difficult context that our teams have addressed. It's in Myanmar, and it's addressing the needs of displaced population after a coup in 2022. So what you see is that this is an example of one of their installations, and it's as I mentioned, it is largely for internally displaced people, but it also they also have applications to remote contexts where electrification is either delayed or it's simply not happening. And the magnitude is enormous. There's 1 million internally displaced people in Myanmar, and a large number of camps without electricity access. So what they do in these contexts is they have a suite of solutions, whether it's off-grid solar home system, whether it's community microgrid that operates as energy as a service, and on top of that, they also have internet access in certain contexts. It's really looking at what is what are the needs of the community? What does the community look like? The camps, and then providing the right solution. And there is a layer of complexity on top of the affordability and the technology solution that is reaching these communities. And I think we were all really impressed with how this company goes about leveraging the right type of kind of pathways and societal stakeholders to get to these communities. So it's a really, really difficult context to work in. And the winner of the category of end user solutions is a clean cooking company. It's a company that develops domestic biodigesters. So it's really waste to energy solution that enables converting organic household waste to biogas, which can then be used directly for cooking or can generate electricity. And actually, in their case, does both. This is what a solution looks like, and they tailored it to do 2 different sizes. So there is a version for single households, and there's the version for let's say a farm or a larger household. And what they show is what kind of waste can be used and how much gas for cooking it can generate and how much electricity for a household it can generate. It's a really solution that's addressed some challenges that other biogas solutions have encountered in the field. And it is enabled, it uses IoT to both meter the consumption, but also to gather the business intelligence that I talked about before. And the second last solution, I think I need to speed up, is the best decentralized solution, which is a company active in Cameroon, SolarWorks. And what they're doing is they're really looking at how do we connect these individual solar home systems to a bottom-up microgrid. And they do that with a number of goals. So it's basically to enable sharing of resources, and that it also enables different type of consumers to take part. So which you can see here, there could be a larger installation that's connected to this decentralized microgrid. So it's not a centralized microgrid as we've seen in the previous solution, but it's really decentralized generation storage. So you could have larger prosumers, you could have single households that are prosumers, but you can also have only consumers. You could also have consumers that are connected to this decentralized grid. And the way they leverage their technology stack, the communication, is to also be able to kind of tailor the offer to what their customers need. So you can also see in top right that the energy that they produce by the microgrid, or this decentralized microgrid, is quite close to what they built, so which is of course desirable and this is not something that we see often in case of mini grids. And then the winner is in the same line of thinking of a grid or a mini grid that is growing bottom up. And they've really approached it from the perspective of, yes, the short-term challenge is to connect people to reach energy access, but what we're actually doing it for is to enable sustainable development. And the way they do that is by starting with nanogrids, so really small, several household nanogrids, so really small infrastructure that can actually be connected, grow into microgrid and mini grid, and power more and more appliances as the demand grows. And that enables powering productive use of energy. So agricultural loads, workshops, even hair salons and so on. And what is interesting about this is that this is the second time they took part in the competition. And between the first and the second round of competition, they created this partnership with the university in France that actually enabled them to figure out how to go from an nanogrid to a microgrid and combine that with a business model on the ground in Madagascar. So it's a really an interesting example of partnership that was created through this initiative. And with that, I would like to announce that we are launching the third round of Empower Billion Lives. So the competition is open for teams to register. We are going to work with a timeline starting now, accepting registration of teams and ending with a global final in December 2025 in Johannesburg in South Africa. In between that, we will have a number of rounds where teams submit concept papers, then they get feedback so that they can improve their proposals, then they go into the full proposal round, and a part of the full proposal round is field testing. So teams really need to demonstrate their solutions in the field, including business model and planned impact. And together with this timeline, we have a number of events that serve to both enable the competition, to really allow matchmaking between teams. I will talk about it in a minute, and to bring the stakeholders together to drive this conversation on what is needed to scale energy access further. So with that, this time around, we have a number of tracks again, and what is different this time around, we have a new track that is really aimed at local entrepreneurship, so local businesses who then can be matched with the first category, which are technology providers. So because we see this value chain disintegrating, so there is technology provider on one side, but they cannot reach the end user, so that this partnership can really enable that. And we also have a category, energy resilience, which is really inviting teams from all over the world, but inviting teams who do not necessarily have access to testing their solutions in the energy access context in say Sub-Saharan Africa or Southeast Asia, but can demonstrate these solutions are also able to address the needs of context where energy resilience is really important. Think of natural disasters, think of blackouts where solutions need to be deployed quickly, they need to be affordable, and need to work well. So it's really this, again, connection between development in the global north and solutions that can be developed, and how can that be leveraged for energy access. And then again, we have the category of student teams, where we invite student teams from all over the world, and their testing requirements are lighter than for the companies, let's say for tracks, technology provider and local entrepreneurship, so they can demonstrate their solutions in the lab, and they compete in a separate category. So with that, I would like to invite you all to engage with Empower a Billion Lives, either by participating in the competition or promoting the competition, so that we can engage more teams. To contribute to events, I think Deepak will talk about ideas, the conference that we are organizing, but also to respond to some of these questions that we get from the sector on roadmaps, on different kinds of input, to volunteer and to contribute in maybe new creative ways that we haven't thought about. So feel free to reach out to us. And with that, I would like to hand over to Deepak.
Great, thank you. Hopefully I can share my screen. Give me 1 second. You don't have to do. Okay, is that visible to everybody?
We can see the presenter mode.
Okay.
Sorry, we can see the, yes, that's good now, yes.
Good, all right. Well, thanks, Yelena. I will try to build on what you said. Again, I think we're a little shy on time, so excuse me if I go a little fast, but hopefully have time for a couple of questions. So I'm going to kind of talk slightly differently from what Yelena did. You know, I see that, you know, energy access has always been kind of constrained in terms of funding. We've always struggled because it's always kind of serving communities that don't have a lot of people. But for the first time, I think we see an opportunity for a convergence between energy transition, which is where a lot of the money is being spent, and energy access. See, these are the ones in a lifetime opportunity. All right, so let me go. I'm not going to spend any time on introducing me. There was quite a bit of an introduction earlier. So let's talk about the energy industry as we start right now. We see a massive disruption that is underway, and as recently as 2010, there wasn't you know, a single CEO from a utility, an oil company, or an automotive CEO who believed that EVs, PV energy storage would be cost competitive anytime soon. And within 5 years, everybody was scrambling because, you know, they were not able to cope. We today are sitting at a point where, you know, we were not able to forecast what was going to happen, and yet we see massive and rapid growth of these new technologies. PV and wind is growing, storage is growing, green hydrogen is growing, EVs are growing, AI data centers are coming in, industrial loads are coming in, and we have issues of resiliency and equity as well. So I mean, all this change is happening. What is driving this change? Is this why is it that these sectors that represent such a big part of global GDP and all the consultants couldn't see the tsunami coming? Will tomorrow's grid be an evolution or a new paradigm? And if you were to build a new greenfield grid today, for instance, in Africa, should it look like the current grid? I think these are very important questions that we need to talk about. But let's first understand, what is driving this massive and rapid disruption. No surprise out here, it's really PV, solar, and batteries. Okay, we see very steep and sustained learning rates. We see that there's been about a 97.5% decrease in prices in solar in 22 years and continuing. Nobody who was running a real business in 2000 or 2010, would ever, make a major investment on the hope that PV solar would be at a price that it is at currently. Same thing is happening with batteries. Okay, and these technology trends are continuing. So we see that the prices are going to continue to decrease over the next decade or even more. What is the impact of this on the overall system? Well, let's see. We see that here I have a couple of charts out here that are kind of interesting. We see in the U.S. situation in 2020, we had about 1,000 gigawatts of total generation, connected through transmission to a whole bunch of load at the edge of the grid. Residential, commercial, industrial, transportation, all of that. If you look out 2040, we see a significant increase in the load and the demand. We see a significant increase in the total, generation capacity that wants to connect, but we don't see a big increase in the transmission that is going to connect the bulk generation to grid edge. As a result of that, we see that the grid is not able to serve the new loads and is driving growth of distributed behind the meter resources. We see distributed generation of almost 800 gigawatts wanted to connect and drive the development of the data centers and the EV fast charging centers, things like that. So, we see that reflected back here on the lower chart, right chart, where we see the 2010 to 2022, we see the interconnection queue grew to almost 2,000 gigawatts. By the end of 23, it was 2,600 gigawatts. When you compare that with 1,000 gigawatts of total generation capacity we have in the US today, we see the problem and the scale of the problem out here. Almost 95% of this new generation that wants to connect is really, inverter-based resources. Well, that's a big problem by itself. That's a whole new paradigm. We are seeing whether it's solar, whether it's wind, whether it's battery energy storage, all of those things are really inverter-based resources. And it represents a very different paradigm. We go from a centralized passive grid to a decentralized active grid. And the challenge of controlling millions of these, geo-dispersed, inverters from different vendors, owners, and proprietary IP, and to have it operate autonomously with poor system visibility and knowledge becomes really a very big challenge. How do we ensure stability? How do we ensure that under normal and abnormal conditions, the system is going to be able to operate? So this is a very big problem that we are trying to tackle in the global north at this point in time, and we do not have really good technology, economic, or policy solutions. We also see there's a very big gap in terms of the standards and how the standards are evolving. The standards are lagging by almost 10 to 15 years. And although we can kind of come up with an idea of where we want to be eventually, how do we go from where we are today to that point if solutions that conform to new standards are not going to be available becomes a really big issue that we need to kind of understand and address. Okay, so this is a kind of a very high level discussion of where things are at. Let me kind of jump to, what is it that we would like the new grid to do, both in the global north as well as in the global south. We see there's a major disruption occurring, as we discussed. We don't know what the outcomes are going to be. There's going to be impact across everything from generation, storage, transportation, industry, data centers, commercial, and residential sectors. In the developed nations, we do want to preserve our investments because there's a big amount that has been put in the US, about $3 trillion. In the grid, you don't want to necessarily lose that. But as we look at these solutions, we see these solutions are decentralized, and we want them to operate in grid-connected or islanded modes, and forming microgrids for resiliency and demand response, and also to augment existing grids. So this is what we want in the global north. In the global south, we see a greenfield opportunity to leapfrog to a new 21st century grid, where we want solutions that are decentralized or more modular, flexible, interoperable across vendors. And you've heard Yelena talk about some of these concepts out there. I call it a true democratization of energy. And if we can kind of get there, this would be really good. We see that this needs new principles and new fundamentals. You know, we think of the grid essentially as an ecosystem where you have a lot of inverters, millions eventually, you know, collaborating to kind of control the overall system. How do you manage a complex system like that? Today's system, you know, kind of thinks of itself in a centralized paradigm, where the grid operator is essentially dispatching every device with full knowledge of the system, and you have to now you know, layer on that cybersecurity and communications issues, and what happens when you have faults. So this is a very difficult system, you know, to extend out to a concept where you have millions of autonomous inverters that are also a part of this mix. So this is what we are looking at in terms of very complex systems. We actually have solutions for that today, you know, when you drive a car and in nature itself. So we call this collaborative control, where we look at these intelligent grid-connected devices and inverters that use local measurements, you know, and standard rules, act in real time, fulfill their own goals, suppress interactions, and collaborate to sustain the grid. Such systems, if we can design them, can operate with poor system knowledge, flexible goals, and adapt to varying conditions. It's a very different paradigm. It seems aspirational, and the question is, you know, can we do something like this? And yes, we have been doing this. I mean, I think, you know, we've done this in a company setting at Verintech, where we showed for the first time that collaborative control principles with autonomous devices, you know, at scale can really work on the grid. And that was one of the first demonstrations of that. On the left, we've been kind of experimenting with the idea of fractal decentralized multi-agent kind of systems, which can operate over a very wide range of energy availability. So this is the kind of microgrid architecture that we would really like to see, which doesn't rely on a lot of communication. I think, you know, Yelena talked a lot about, you know, the complexity and the fact that if you have to have people who are skilled, you know, in villages and remote areas, becomes very difficult to implement this. So, you know, how much automated can you make this? How simple can you make this to actually deploy? We also have been kind of working on this idea of collaborative control over connected inverters. You know, don't have time to go through this much, but, you know, we have been able to demonstrate the ability to have decentralized control of multiple ad hoc fractal microgrids, which can be disconnected and disconnected at will, where we can kind of have these systems stable and operating over a wide range of energy availability. So yes, so I think the technologies are starting to come in place. You know, in the global north, the challenge right now is how do we get to capacity expansion, get to it fast and at low cost? And we see that a lot of these distributed generation resources that are now being deployed are being deployed outside of utility control, because if I want to build a data center, I'm not going to wait for 10 years for the utilities to bring power to me. If I want to build a charging infrastructure, I don't want to wait for, you know, 10, 15 years for the grid to come. So, you know, all of these things are now starting to get decentralized and distributed solutions that are powering everything. We see a lot of this being deployed where local generation is being used to power data centers, for fleet charging, and for microgrids and turbines. So we see this opportunity also at the industrial level and at the home level, where we see the electric vehicle, for instance, you know, has enough power to back up a house for a whole week, you know, and yet the cost of connecting EVs, you know, to residential backup is still very, very expensive. We're working on solutions for that, and I think there's opportunities out there. The other thing that's kind of interesting also is we kind of looked at the you know, the opportunities if you have industrial warehouse where you have solar energy on it. We looked at a major US city, and we saw that you could, in 2 years or 3 years, you could put 1,000 megawatt peak generation kind of facility using distributed warehouses, which could provide EV charging for 10,000 EVs at the same time. And you could have 1,000 megawatt of clean generation, all without any new grid build. So this is the kind of thing that was starting to look very interesting for the energy transition. The question is, what does that do for the energy transition? How does this apply to energy transition? As Yelena showed, the 20th century centralized grid is not the answer. We've not been able to make that work. Okay, and what we need today are these solutions that are more modular, kind of intelligent, decentralized, and can be designed to scale at any level. We see that these things are now really possible. If we can design and build these systems from the same components that are used to build the bigger systems, then we can write the same learning curve, and you can now realize these plug-and-play modular interoperable systems pretty much at any scale. We also have an opportunity to think about this in terms of tier 1, 2 capability is achieved at the single homeowner level, tier 3 at the small group or community level, and tier 4 or 5 at the grid level. And you start essentially building smaller systems, a bottom-up grid, which then can continue to operate in the future as required. We see a lot of applications, and I think Yelena talked about this quite a bit. It's important that productive end-use applications be the primary focus, because that is going to start revenues. It's going to start income generation for the people, and that is what gets their lifestyle to go up. So whether it's agricultural, whether it's industrial, commercial, or social, we see lots of opportunities where we need power in the 500 watt range, maybe a kilowatt range, which can really change their life quite dramatically. So here's an example of a system that we've been kind of building and thinking about is an energy ecosystem, because when you think about the customer out there, they don't really know DC, they don't know AC, they just want to use appliances, they want to get the functionality they want, and we're starting to see some progress out here that is really very encouraging. We see these swappable battery packs that can give you maybe 500 watt hours, maybe a kilowatt hour, which is starting to be used for tuk-tuks and for electric scooters and for transportation type of purposes. You kind of build a system on that where you can marry that with PV and put in a energy kind of converter, which gives you both, the 48 volt DC, the USB for lighting, as well as AC for running your appliances. And if you can do that correctly and at low cost, I think there is an opportunity here to kind of start thinking of a DC AC agnostic type of system. You can take this one step further, and we are doing this right now, where you can kind of think about integrated solar panel plus energy storage plus power conversion building block, which you can then stack together to provide single homes or community, kind of microgrids or utility scale type of solar. If you can do that with the same kind of building block that is used in the global north, you now get manufacturing kind of scale that makes this cost very low. And if you design these things correctly for interoperability, then you become technology agnostic. This is what we've been calling a true democratization of energy, but such a system is now definitely, viable. To begin to wrap up, I think, yes, we need a lot of technologies out here. One of the reasons to start PC12 is that, power electronics, so far, we've been kind of using it to solve narrow problems. I think as the technology matures, it's time to kind of turn around and solve some of the big societal problems. The whole energy transition and energy access are some of the biggest issues that we have. We have to think beyond just pure power electronics converters into how do you apply these technologies to solve the fundamental issues that society faces. There's a lot of technology elements to this, and we've discussed this within the PELS community at a few times. We can kind of take these aspirational requirements and turn them into technology specifications and needs. And these are very difficult at this point in time, and I think can be kind of the basis for many sessions, for many conferences. Ideas is a big conference that's coming up that is going to really kind of focus on this. So it allows you to kind of address issues of flexible DC or AC, nanogrids, microgrids, interoperable across multiple vendors, real-time dynamic pricing, dynamic balancing in real time, pay-go integration. All of these issues become kind of really important from a technology standpoint as well. The non-technical issues are very challenging. I'm not going to talk too much about this at this point in time. These slides will be up later, so you'll get a chance to kind of look at this. I think Yelena mentioned the new conference that is coming up. This is the International Decentralized Energy Access Solutions, or IDEAS conference. The next one coming up is in Bali, Indonesia, January 7 to 9. Indonesia is a great place for energy access. They have 10,000 islands that really kind of form the foundation for how power is delivered to a lot of the communities. You'll see a lot of technology tracks out here, and you'll see impact tracks as well. I think the call for papers deadline is September 1. So encourage everybody to to kind of get in there as well. Once in a lifetime opportunity. I'm sorry I had to go a little bit fast out here, trying to make sure we finish at the time and have a chance for a couple of questions. But we see this a once in a lifetime opportunity. We take these exponential technologies where the cost is going down dramatically as the volume goes up, and to leapfrog the existing grid and get to a whole new way of delivering energy. I want to make sure the poorest will not be left behind again out here. If we can align the solutions from the global north and the south, we get some steep learning curves you can ride on, and the challenge is to make sure these solutions are holistic, address the related issues, and can kind of cover the issues for last mile in terms of skills needed, buying power, productive uses, and address some of these big needs for cooking, transportation, and cooling that are important. Models should be built on tiered services, basic assured access with high reliability costing more, with scalable, flexible, interoperable solutions. It's important to realize and to kind of accept the fact that we were not able to predict the energy disruption we're facing today. Why do we believe we can predict and plan for what's going to happen tomorrow? It's both a challenge and an opportunity. Again, just a plug on the book. I think a lot of the things that we've talked about here, are really there in the book that we published, Energy 2040. So with that, let me turn it back to you, Isa. If we still have some time for questions, I'm happy to do that.
Thank you so much, Deepak. Can you hear me?
Yes.
I can hear you, yes.
Oh, thank you so much. Wonderful presentation from Elena and you. I think the framing was outstanding in terms of the energy access challenges we are facing out there and what EBL has done from 2019 all the way to now, with the third competition coming up next year or 2025. And I really, I read your book, Deepak. I'm halfway through. I have to tell you, you really put the conversation on the platform for everyone to join. And I think Mike's remark on LinkedIn is on the spot. What I will, I'm going to turn it over to Brianna, see if we have any questions from the audience, because I think I didn't see any chat questions. Any questions we have?
There's just one comment here, more of a comment than a question. It says, I think it's still useful to remind the audience that grid extension did not work as a strategy for rural electrification in the 20th century US. Instead, new local entities and business models had to be invented. As you point out, business models continue to be critical.
Yes, I mean, also in the US, I think, and in the developed countries, I mean, it was really the PUCA Act in 1934 that, moved us toward the regulated industry. I think there was enough wealth that we were able to kind of force that universal access to happen. But that is now slowing down the utility sector out here quite significantly. I think we want to make sure that as we get to Africa and to parts of the world where we have to build a new system, that it looks different from what we have done before.
And then another question, do you think the billions of dollars and euros devoted to climate change will be available for the problems and solutions you presented, or will that money continue to be allocated to existing grid solutions?
Maybe I can jump in here. I think the answer is both yes and no. I think there is a growing awareness that the climate financing can be and is in some contexts redirected to energy access. There are examples of clean cooking solutions funded by Green Climate Fund, so that there is, but it can definitely be scaled and leveraged more. I think that's another interesting development that we see also in terms of climate funding is carbon financing. Both in electrification, but largely in clean cooking, but it comes with its own set of challenges of transparency and of actually making sure that the reduced emissions that are claimed that are actually realized. So you may have read articles in Guardian and so on, where some of these projects have been questioned. So another interesting development is climate resilience. So adaptation and resilience are getting more and more prominent next to mitigation. So there are some interesting developments going there. But yes, that's probably the source of financing that will be important in energy access.
Maybe I can add a little bit to that. I think I generally agree with you. My worry, on the other hand, is that the scale of funding that is going to go to the global north to develop solutions is probably 2 orders of magnitude more than will go into the global south. And I think I'm looking to see how we can break that cycle. So one of the things that we've been talking about is, yes, if we can kind of come up with a way to build grid that is really kind of is much more economical, more sustainable, has better capability. Can we do a country scale pilot, or can we do a large pilot that kind of demonstrates the functionality? I mean, there is no way to kind of build a future grid in a location like the US where there's a massive grid that already exists. But can we go to another country or to another community and kind of demonstrate all the functionality that we're talking about and the economics and everything else? Then I think there's a chance to kind of make that go forward. If we can kind of harmonize on the solutions that we use in the global north, then the cost will go down to the point where you can begin to deploy those directly in these emerging markets as well. So that's one way in my mind of increasing the funding that goes in. But, to kind of look only at traditional sources of energy access funding may be limiting in my mind in terms of how rapidly we can scale it.
Brianna, do you have a quick question? I have a quick question if we have time. I know we are few minutes over.
Sure. Yeah, no, go ahead.
Lena, I'm not sure if you mentioned the amount of money available for the third round. Did you mention that for EBL? Can you elaborate?
No, I haven't mentioned. I think it's what we had in the previous 2 rounds is in total €1 million. So I think we're looking at at least 300,000 this time around. I think that's the latest number I have. But yeah, it's still developing.
That's great. So if we meet even last year, I think at Deepak we gave 600+ K on the global. All right. So this is great for membership in TC abroad. It's a lot of money on the table. Any more questions, Brianna?
No, that looks like it is all of the questions. On behalf of PELS, we would like to thank all of our speakers and our panelists for their time today. Just as a reminder for those on the line, information on how to request a PDH certificate will be included in the follow-up email you'll receive within 1 hour of completion of the webinar. For more information on our upcoming webinars, you can visit our website at IEEE-PELS.org. And I believe that will conclude today's webinar. So I thank you all for attending.
Thank you
so much.
Thank you so much.
Appreciate it. Thank you.
Hey guys, great.
Bye.
Bye.